analyzing graphs and quadratics. So we're going to find the vertex, the axis of symmetry, and the maximum or minimum value of the quadratic function using the method of completing the square. We're going to graph the quadratic function, and we're going to solve problems involving maximum and minimum functions. So here we have this quadratic function and the formula written in this format. We have noticed that our previous quadratic functions are written f of x equals ax squared plus bx plus c. However, we could see it written in this format, and when we do, we're going to recognize that h comma k is going to give me my vertex. Okay? Now, in this place here, h is going to be the x coordinate and k will be the y coordinate whenever we go plot it. The vertex, though, is going to tell me where the belly of the parabola is at, where it's located. Okay, so this here would be my vertex. Okay? All right. So now, knowing this, as long as we remember that our function is written in this notation, and we're giving a particular function. So for example, we're given this function here, f of x is equal to 2 times that x plus 3 all squared minus 2. I notice that we have a plus 3 there. And if I have a plus 3, I can rewrite it as negative 3 minus, right? Negative and negative here. Because negative times negative gives me a positive that gave me back this. But this here, this bottom line here is written in this format right here. We also know that this k value here is negative and the formula value is positive. So if I separated it and said positive or a plus, that negative 2. So that gives me another outlook. So now I know what the vertex is. The vertex is negative 3, comma, negative 2. So I'm going to go on the graph. You start at 0, 0, and you're going to go x first. And since it's negative, we're going to go 1, 2, 3 to the left. And then we're going to go down 2 because y is negative, and we'll get this part right here for our vertex. Okay, so we're going to find other points to determine where these arms go. We'll talk more about those in a little bit. This function here, it's written correctly, right? You notice the h has already got the minus here and the k's got the positive here. So I know it's 1, comma 3. It matches our original formula, right? So I'm going to plot, I'm going to go to 0, 0 and go over 1 for x in the positive direction and go up 3 for y in the positive direction. And I got my vertex. So I know where my belly is landing. However, we notice that this one and this one opens upward. How do I know it? Because here on this particular spot where A is, right? If A is positive, the parabola opens upward. If A is negative, it opens downward. And as you notice here, we have the negative value. This is written correctly as far as the formula goes. There was no alter, they didn't alter the signs. So I know that it's 1, comma 3 again, and I'm going to plot that point. However, since it's a negative value, I know it's going to flip down. We just don't know where it's going to cross on the x and y axis until we look for the intercepts. So here we go. We're going to find the vertex. Well, if you notice, this is written in standard form. It's not exactly written in the formula that we just saw. F of x is equal to a times x minus h squared plus k. It's not written like that. So we need to get our perfect square here. We need to get a pulled out. And if you notice in this section here, this line right here, what they did right here in red, how did they find that? Well, they scooted a space between our bx and our c here to fill in the spot that will make a perfect square. And how they know that it was that? Well, they took b over 2a and squared it. Well, b in this case is 10. 2 times a, well, a is 1. Square it. Well, half of 10 is 5. And when I square 5, I get 25. And remember, it's positive, so I added it here. But remember, we have to do the same to this part. We can't just add it to one part and not at all. They separated it with the parentheses here. So I got the 25, negative 25 plus the 23. And as you notice, that's where the negative 2 comes from. Now we have x squared plus 10x plus 25. And we can write it as a, we can factor it down and then write it as a perfect square. So we know that x is going to lead it off. I know that 5 times 5 is 25, but I also know that it adds, because remember the sign on C, add, there tells you if you add or subtract, to give me a positive 10. So the signs are both going to be positive because B is positive, and we're adding, signs are the same. And 5 times 5 is 25. It's also 5 plus 5 is 10. Now I can rewrite it in this format, and that's where they get this part. So now I have x plus 5 all squared minus 2. Well, the formula said that it is x minus h. So what I'm going to do is break it down one more time. I'm going to say x minus the negative 5, because you agree negative times negative is positive. Voila. Minus 2. Now I know what my vertex is. My vertex is going to be negative 5, comma, negative 2. Now, I'm going to go back to this other slide just for a minute, and I'm going to show you something. When we were plotting that, we didn't state what the axis of symmetry is. The axis of symmetry is this dotted line right here. It's actually what splits this parabola in two. Okay? And it's actually my x value. So if your parabola opens upward or downward, my axis of symmetry will be the x value of the vertex. Okay, if it's, and in this class here, you will be solving for the y equals in respect of x. Okay, the further up you go in math, you can flip flop those, and if you do, and it's x is equal to respect to y, then it will open side to side. So I just wanted to let you know there is a possibility of that happening, but just in this class, we usually just stick with the y equals. So my axis of symmetry here is negative 5. So it's x equals. You got to state x equals, because you can't just say negative 5, because I mean, we have an x and y coordinate here. We have a minimum value of negative 2, which makes sense because if it's opening upward or downward, we know that this would be a max, right? This would be a minimum. So let's look at the other slide again. So if I was to tell you this minimum or max, well, I agree it's a minimum because it's, you know, it's opening upward, and the minimum value is going to be whatever y is. In this case, it's negative 2. Over here, it's opening downward, so I'm going to have a max, and it's going to be y is equal to, in this case, 3. So when I look at this one, I see that my y value here, which is k, is equal to negative 2. So y equals negative 2. And it gives me a minimum because we're opening downward. Excuse me, we're opening upward. My apologies. And how do I know we're open upwards? Because a is right here. It's a positive 1. There's no number right in between the equal sign and this bracket. Now let's talk about this next example. This next example says we're going to graph this. So I have this function right here, and we agree it's a parabola, and I see that the coefficient here on x is positive, so I know it's going to open upward. And I'm just going to do a simple x, y, right? We are going to plug in these order pairs. Now, one, we already solved for this in this format. So we know what the vertex is. If we didn't know what it was, we do need to solve for it so we can determine where it's plotted at. We do have this graph given to us already, so we could tell that it's right here at this point. Again, it would do good to make sure that you understand how to solve these. And this should have been a negative, so I'm just going to rewrite it one more time. Anyways, so here's our vertex, but I want to find all my values. So I want to know, where does it cross the x-axis, the y-axis? Does it even cross? So what we could do, yeah, you can create an XY table, plug in a point for X, find Y, and both back and forth, back and forth. Or we could say, okay, well, if I did the XY table and I put in 0 for X, well, I put 0 in for X, 0 in for X. I know Y is 23, so I know it's going to cross the Y-axis somewhere way up here, right? If I set it equal to 0, then I need to factor this down. So we're going to do the quadratic. So it kind of gets a little messy. And if you notice, it's not going to be exactly like we want it. So sometimes it's better to pick values like -1 and 2 and -2 and 1 to determine where we're going to cross at. Now in this one here, let's find the vertex. So what I would want to, in the x-axis or the axis of symmetry, the maximum, minimum. Well, I know since it's before I even say anything, let's rewrite this. Let's just rewrite it in a format that looks more readable. So I'm going to break this apart. I'm going to have half. So I'm going to pull this half off of that x squared. All right, there we go. So now what do I want to do? I want to write this in a form that the C is isolated. So let's do that. So if I do that, I do know that I would have half. And in parentheses here, right, I'm going to have x squared because I pulled out the half. And then when I factor out the half, what happens, I have to apply it to the bx. Sorry, I kind of paused there for a second. Well, how do I find out what bx is? Well, we know it's -4x here, right? That's what we got, but we're wanting to write it in another format that we can solve for it. And there's another way to find the vertex. I could show you in just a minute. We'll definitely get to it, but here we go. So we have, when I factor out this here, right, I'm going to factor out the half, like the GCF of it. And when I do that, what happens is I end up multiplying this by 2, right? Because we have to undo it. So, okay, let me just say this. I got half x squared. And then I have the 4 divided by the half, because I'm trying to factor it out. Remember, I said if I'm doing the GCF, I divide it by this. I factor out the GCF, and let me rewrite it a little neater. Let me slow down, let me catch back up. So first things first, I want to factor out my GCF. And I notice my GCF right here is going to be the half. I'm not worried about the constant. Constant's going to go by itself. Remember, we got to isolate it. So if I factor out the GCF, that's the same as saying that, okay, I'm going to pull the GCF out. We know it's a half. That means I'm going to divide this first time by it. It gives me x squared. I'm going to divide this -4x by the half. That means I need to rewrite it where it's 4 divides half. Don't forget the negative, which is 4 times 2/1. Remember, keep, change, flip. So now I get a -8x. Okay, so that's how that came about. So I'm going to just scoot this 8 over. So far, so good, right? So we need to figure out how we're going to write this in a format. And if you want to notice that, here we go. Let me clean this up. Just wanted you to see how they have it written right now. So now we need to figure out what's going to give me my perfect square, right? Now I'm going to, just for myself, rewrite this like this, and I'm going to give myself some space. But don't forget what we did on one side of this parenthesis, I'm going to do over here, so it wouldn't hurt to allow yourself enough room right here. for it. Okay, so I'm going to find what makes this a perfect square here. Remember, we're going to take 2 or b over 2a and square it. Well, b in this case is -8 and a is 1. Okay, so I got -8 over 2, which gives me what? -4. And when I square it, it gives me +16. So I'm going to add 16 here, and I'm going to subtract 16. So now I got a half. And I'm going to rewrite this in a perfect square. So again, if I come back, let me show you right before we squared it, after it's cleaned up right here and before we square it, that's my answer in this parentheses. So I got x minus that 4. And then I'm going to put the square right here. Okay. And now I got, sorry guys, I skipped a step. Don't need to, because some of you will be like, how'd you get that? And my pen is just not back to right. There we go. So now I'm going to say, okay, this is where I get that. And then -16 plus 8 gives me -8. And this gives me this. So that's where I came up with that. Now it's written in a format, I could tell you what the vertex is. Now remember, the original formula says that we have f of x is equal to ax minus h squared plus k. So if you notice, this is a -4, so it's correct. So my vertex here is going to be 4. But this here is a negative, so that means that in order for that to be a positive, it's going to be a -8. Okay, so now my vertex. I know that my axis is symmetry is going to be my x equals that 4. This is going to split that parabola in half. It's going to open up, right? Because this here is positive, so it's going to open up. So I'm going to have a minimum, and it's going to be at my y value. And I just solved it. And I can graph this just with this much information. And you check your work, and we graph it. We're going to plot our, and we got a new formula here. Okay. So this one here is written, this is this, and then it's been solved into the formula notation. If some of you are confused again, we figured out the GCF between these two here is a half. So I pulled the half out. And when I did that, that means x squared halves is divided by a half. And it's this right here. And that means we keep, change operation, flip. And what happens? The 2's reduce and leaves me with x squared. And that's how we got the x squared. We're going to do the same to the 4, -4. So we got -4 divided by a half. Keep, change, flip. And now we got -8. So the x here plus 8 here. Okay, we almost got what they have here. Now what I need to do is find the perfect square. So we're going to take half, or we take b divided by 2 times 1, or a here. Let me just square it. My b is -8 divided by 2 squared. So it's -4 squared, which is 16. So now I have x squared minus 8x plus 16. And close parenthesis, minus 16 plus 8. And then we are going to rewrite this, and we've solved this before. So we have a -8 here. They came up with a 0 here. So this could be a typo, either that or they just said, hey, let's graph this one. There's not a whole lot of instructions on this one here. So it's telling you, let's graph this one. This one here, we solved it earlier. So if we're using this one and this is what they gave us, then there is no K written here, then we know K is 0, right? And so our vertex is 4, 0. Our axis symmetry is x equals 4. And the minimum is when y equals 0. Okay, so if it is written, your quadratic's written in standard form, this is your formula for the vertex. So to find my x, which is h, we can take this formula of negative b over 2a. And then to find my y, which is k, we can say f of that, whatever that value was, we plug it back into that function, and it would give us our answer. So let's look at one. So I want to find the vertex here, and I don't want to have to write it in this format. I mean, we just did some. But if we don't want to write it in that format, well, we could say, oh, okay, this is what we have. And we can find it this way. Makes life a little easier sometimes. So let's do it. So what is A? A is -1, B is 14, C is -47. So let's plug it in. Negative B, and so negative times, so -1 times B, which is B is positive, so, and then A is -1. So I got -14 over -2, which is +7. So now I know what H is. So far, good. It's 7. Let's find what is my K value. My K value is, we are going to plug in everywhere I see X in the function. I'm going to plug in my answer for H, which in this case is 7. So now I got what? -49, because the negative sign's in front of that parentheses, it did not get squared. So I got -49 plus that 14 times 7 minus 47. And I came up with 2. That's my final answer. I just want to check my work. It doesn't hurt. So I got -49 plus 98 minus 47. 2. So now I know my vertex. I know that the parabola opens downward because of that negative sign on the x value. So I'm going to have a maximum, and it's going to be when y equals 2. I'm going to find my range. Oh, this is very good. I haven't talked about range. So it opens downward, and if you notice, there's arrows on it. If it opened upward, there's arrows on it. So what does this tell me? This arrow tells me it's continuously going off to infinity, negative infinity. And we always read bottom to top when we're reading the range. When you talk about domain, you always read left to right. Why? Because we are starting with small values and we go to the larger. Same here, small to larger. Okay, so I'm going to put a parenthesis on infinity, the negative infinity, because you can't stop infinity. You cannot say, oh, infinity stopped right here. That doesn't work. So I'm going to go negative infinity to, well, what is my maximum value? Y equals 2. That is it. And it stops there. So I'm going to put a bracket on it. Okay. And so if you want to know on what intervals is the function increasing and decreasing, well, I know from here to here it increased, and then from here to here it decreased. Okay. And we can look at what the textbooks said on how to answer it. So we're good. Yay. Yay, we did it. Okay, good. That was something I wanted you to see. So they want you to write if it increase or decrease on the interval notation. So yay, so that makes better sense. So if I go back to this particular one, where does it increase and decrease at? And it might have said interval notations, and it did. I apologize, guys. I had to double check. Okay, so if I want to know where it increases and decreases, I know that I'm going to use a parentheses, and I know that we're starting off infinity. So let me draw this again. So we're going out like this. So if you notice, we're increasing. So we're talking about this x value. So we're going negative infinity, and we're going to continuously go to where x hits at 7, parentheses. And then that's the increasing. And then the decreasing is we're going to start at 7, and I'm using parentheses because we're actually we're going up to this point. And then it goes off to positive infinity. Oh, come back. Now let's talk about this application problem. It says maximizing area. A landscaper has enough stone to enclose a rectangular KIO pond next to the existing garden wall of the Englandman's house with 24 foot of stone wall. If the garden wall forms one side of the rectangle, what is the maximum area and the landscaper can enclose, and what are the dimensions of this pond will yield the area? So it's always good if you can draw, if you can draw this out, it makes it a lot easier. So from here to here, we're going to call it the width. So they labeled it as W. So if you go back to that question before, or, the sentence before, it says 24 foot of stone wall. It says the existing garden wall of this house was 24. So we know it's going to be 24, and we're going to subtract 2 of the widths. Okay. So moving on. Now, let's translate. Since the area of the rectangle is given by the length times width, here's our formula. So that means we got 24 minus 2W. This is my length, and this is my width. It's length times width, and it could be a capital L. So now I'm going to distribute the W. So I got 24W minus 2W squared. Oops. I'm going to go to the next slide and use it to write on. Whoops. Oh, it just stayed. It's not going to give me more room to write on. My apologies, guys. So I'm going to come up here to the top. So I got AW is equal to, and I'm going to rewrite it where it's in descending order. All right. And be careful and watch how you do your signs. Now, what we're going to do is we're going to find the maximum value of this, and then we're going to find the dimensions that the values occur. Okay. So I'm going to know that I have the maximum, right? Because once we wrote in descending order, I saw that the leading coefficient is negative. So I know it's going to open downward. All right. So now let's find it. Let's find W, and we're going to let W represent my age. Let it represent my X, right? So I get negative B over 2A, which is 24, which the formula said negative, and it's positive here. So it's going to be negative 2 times that negative 2, which is negative 24 over negative 4, which is 6, right? So now that I know that, maybe I'll give you that. It'll probably just give us some more work. Yeah, here we go. Check. Now, we know the width is 6 feet. Then the length. So my length, we said, was 24 minus 2W. So let's plug in the width. Oops. There we go. So I got 24 minus 12, which is 12 feet. So this is 6 feet is the width. The length is 12 feet. So now if I want to find the area is length times width. So I have 12 times 6. And it gives me 72 feet squared. Yay. And then we can plug it in our graphing calculator to check our points. And it lets us know, check mark, we are good. Now the maximum possible area is 72 feet, with the pond is 6 feet wide and 12 feet long.